Have you ever stood beneath a truly dark sky, where the edges of your thoughts seem to press against something vast, silent, and waiting? Where does the universe end? Is there a final boundary, or does it stretch on forever, beyond anything we can measure or imagine? If space is expanding, does that mean there's a border? Or are we simply trapped inside a sphere of light, defined by time itself? We'll journey outward, through the ancient fog of plasma and light, toward horizons we can describe but never truly cross. There was a moment when space itself rushed open, faster than light could follow, stretching quantum seeds into the structure of everything. And we'll ask why the map of everything looks so flat, so smooth, so impossibly large, as if shaped by something deeper than chance. Could the universe be finite, yet unbounded? A surface with no edge, no center, just endless paths that curve back on themselves? Could space be knotted, looped, or tiled in ways our minds don't intuit, repeating patterns hidden in the sky's quiet geometry? We'll draw the line between what we can see and what can ever reach us, between the particle horizon and the event horizon beyond. A multiverse of expanding bubbles, each with its own physics, its own fate, will honor what the math allows and what remains speculation. Maybe the universe doesn't end at a place, but at a principle, where light fades and the rules themselves begin to unravel. The brink isn't where answers stop. It's where curiosity belongs, where questions stretch farther than light and wonder keeps going. When we say observable universe, we're not naming a container with walls. We're describing the reach of light shaped by time itself. Before that reach existed, the universe was a glowing fog, a soup of charged particles scattering photons in every direction. Then the fog began to thin, atoms formed, and for the first time, light was free to travel in straight lines across space. That ancient light still surrounds us, stretched thin by time, rippling with temperature, known as the cosmic microwave background. All the while, space itself has been expanding, not pushing galaxies outward, but stretching the grid they rest on. Imagine standing in a hallway that slowly expands while a runner races towards you. That's how light moves through growing space. Any galaxy, anywhere, would draw its own sphere of visibility and see itself at the center, just as we do. Just beyond our horizon, more galaxies likely wait, sending light we'll never receive, their messages lost to expansion. Some galaxies we see today are already too far to update us, their light stretched red, their future forever out of reach. We're watching ancient light like postcards sent long ago, each one a frozen moment from a galaxy we'll never visit again. The boundary isn't fixed, it moves as the universe ages. Dark energy stretches space, changing what can ever reach us. Every photon that arrives is a triumph, a tiny victory over distance, delay, and the silence between stars. Inflation wasn't just expansion, it was exponential, a sudden surge that stretched space faster than anything we've ever known. It was the fabric of reality itself expanding faster than light, not moving through space, but making more of it. The cosmic microwave background looks almost perfectly uniform, yet distant regions shouldn't have had time to communicate. Inflation solves that puzzle, shrinking the early universe into a tiny connected patch before stretching it into what we see today. The universe appears geometrically flat. Triangles add up cleanly, lines stay straight, as if space itself were ironed smooth. Inflation flattens space like a balloon stretched tight, smoothing out curvature until the cosmos looks nearly perfect. Tiny quantum jitters in the vacuum were stretched huge, amplified into the seeds of structure we now observe. Those amplified differences became gravity wells, places where matter gathered, forming galaxies, stars, and the cosmic web. Inflation dropped quantum grains into the early universe, like sand into a pond, rippling outward to shape the surface. Was inflation driven by a scalar field, a false vacuum, a phase transition that rolled space into a new state? Inflation may never have stopped, spawning bubble universes with different laws, each expanding beyond the reach of the others. Draw a triangle in space. Its angles may add to more, less, or exactly 180 degrees. That change in sum is curvature revealed. Cosmology groups space into three broad families: closed with positive curvature, flat with none, or open with a gentle negative curve. On small scales, all three kinds of space can look the same, locally flat like a city street under a calm, starry sky. We measure curvature by using standard rulers, such as the acoustic peaks imprinted on the cosmic microwave background's subtle ripples. Another ruler comes from galaxy clustering, the baryon acoustic scale, a faint spherical pattern still echoing through today's large-scale structure. So far, every precise measurement says the same. The universe is astonishingly close to perfectly flat, with curvature too small to detect. Topology describes the way space is stitched together. A flat map can wrap around itself so that edges connect seamlessly. A flat cosmos can still be finite yet unbounded, like a three-dimensional torus where travel eventually brings you back to your start. If space wraps, light could loop around. Astronomers search the cosmic afterglow for matched circles that might betray that hidden shape. Beyond spheres and tori lies the Poincare dodecahedral space, a multifaceted, repeating universe stranger than everyday intuition allows. In the balloon analogy, remember the surface has no center in its own dimensions. Expansion is a change of scale, not a push from somewhere. The geometry and topology of space aren't set dressing. They are the very stage on which the universe's story unfolds. Imagine standing in a dark, fog-filled field, shining a beam of light that fades into mist. The farther it goes, the less returns. In cosmology, two main horizons define our limits: the particle horizon of what has reached us, and the event horizon of whatever can. As the universe ages, our particle horizon grows. More ancient light arrives, revealing regions once hidden in the early cosmic night. Even if a distant galaxy sent a photon today, accelerating expansion means it will never reach us, no matter how long we wait. Dark energy, symbolized by L, acts everywhere at once with the same steady push, driving galaxies apart faster over time. It's like swimming upstream in a river that flows faster the farther you go. Beyond a point, you can never make headway. We are seeing ancient images like postcards sent billions of years ago, their senders long changed or gone by the time they arrive. Only our closest neighbors, like the Milky Way and Andromeda, will remain bound together while the rest drift forever beyond our reach. Horizons also define our causal patch, the region where events can ever influence us and where our own signals can still be felt. The universe's creativity plays out in the connected web we can reach, while beyond it, a vaster realm remains forever isolated. Even now, photons are racing toward us. Some will arrive after billions of years, and others will never cross the final boundary. The edge is not a physical place we can touch. It is a promise that beyond what we know, more always awaits discovery. In 1998, two independent teams studying distant supernovae found the unexpected. The universe's expansion wasn't slowing down, and it was accelerating. Einstein added L to his equations, then dropped it. Now evidence brings it back, reshaping how we understand the cosmos. Black's like energy of empty space, unchanged as space grows, yet steadily pushing everything apart faster over time. Today, dark energy is roughly 68% of the universe, outweighing dark matter and ordinary matter combined by far. Light from faraway galaxies stretches to longer wavelengths as they recede, reddened by expansion of the very space between us. If acceleration continues, star formation will end, galaxies will dim, and the universe will drift toward a cold, silent future. Around 6 billion years ago, dark energy overtook matter's pull, tilting the scale factor curve upward into sustained acceleration. We track W, the equation of state, describing how dark energy's pressure relates to its density as the universe evolves. Some models propose a dynamic field, quintessence, where dark energy slowly changes with time instead of staying constant. Others invoke a multiverse landscape with many L values. We exist in one where galaxies, stars, and life can form. Dark energy pulls the page apart, stretching space itself while galaxies remain gravitationally bound within their local groups and clusters. Amid our questions, dark energy keeps working, not ending everything at once, but carrying the universe into an ever-widening drift. Inflation didn't have to end everywhere at once. Some regions kept racing outward while others calmed, patching the cosmos with uneven swelling space. Where inflation finally ends, hot energy condenses into matter and light, a phase change that sparks a new bubble universe's birth. Step back far enough, and you might see a drifting foam of countless universes, each bubble expanding, separated by ever-growing gulfs. From bubble to bubble, the rules could differ: forces, particles, even dimensions, a patchwork of physics stitched across the larger inflating backdrop. If another bubble brushed ours long ago, it could leave a subtle circular bruise in the afterglow, a faint ring in the sky. Some theories sketch a vast landscape of possible vacuum states, each valley a different set of constants that inflation could populate. We shouldn't be surprised to find ourselves in a life-friendly bubble. Only in such a place could observers arise to ask why. Critics say the multiverse risks unfalsifiability. Supporters answer that inflation naturally yields it, and we must test whatever predictions survive. Imagine an endless library where each book writes a universe's constants and history. We're reading one volume among uncounted shelves. In this picture, the Big Bang isn't unique. It's one of many beginnings scattered across expanding bubbles, each unfolding alone. Our cosmic horizon is simply the boundary of our page. Beyond it, the larger story continues, unwitnessed but not undone. Elsewhere, new pages keep forming and drifting outward, their tales beyond our reach. Yet reality keeps writing, line after line. The Milky Way and Andromeda are on course to merge, their stars arcing in tidal streams as two spirals become a single remade galaxy. Collisions squeeze gas and dust, igniting blue clusters and bursts of star formation, brief fireworks before fuel thins and settles. Beyond our local group, distant clusters redshift and fade past the event horizon, their signal stretched beyond any hope of arrival. Small red dwarfs will outlast the giants by trillions of years, burning slowly in dim systems while the universe grows quieter. At galactic centers, supermassive black holes endure, lensing starlight as nearby stars precess in tight, fragile, relativistic orbits. White dwarfs cool through eons, slipping toward black dwarf silence, embers of suns that once lit spiral arms and stellar nurseries. With fresh starlight scarce, the sky thins to a few dim embers, parallax slows, and darkness claims the spaces between. Even black holes aren't forever. They radiate faintly, bleeding mass through quantum effects, shrinking imperceptibly on unthinkable timescales. When the final black hole exhales its last photon, that whisper of light will vanish into an already ancient, emptied night. If dark energy grows stronger with time, a big rip could tear the grid of space itself, unbinding galaxies, stars, even atoms. Under a steady L, expansion accelerates gently. The cosmic background cools toward zero as structure freezes and distances widen. At the end, only a few red candles flicker on a dark horizon. The last light endures quietly, then yields to night. First, we separate what we've seen, what we've reasoned, and what we still imagine, each with its own purpose. Observation, inference, and speculation. Observation maps the sky in photons, galaxies traced, afterglow measured, supernovae charted, each one a tested clue to the cosmos. Some pictures comfort but mislead, like walls at the edge of space. Let them dissolve and keep only what physics demands. Edges in cosmology aren't cliffs or endings. They're categories, what we can see, reach, model, and ask meaningful questions about. A good idea doesn't just explain, so it predicts. It stakes a claim beyond the data, inviting us to test it against the future. Topology predicts repeated patterns, like matched circles in the cosmic microwave background, echoes of a universe that might wrap around itself. Respecting ignorance isn't giving up, it's discipline. We name what we don't know and keep our claims sharp, honest, and provisional. We never saw a dinosaur walk, yet bones tell their story. We never see the sun's core, yet neutrinos reveal its fire. Even beyond our horizon, the cosmos can be inferred, carefully, using rules that work here and watching for cracks that might appear. Meaning isn't built into the universe, it's made by minds, drawing connections, telling stories, and choosing what matters in the vastness. We say only what the evidence earns, an expanding, nearly flat universe, rich in dark matter, seeded by quantum fluctuations driven by L. Between what we know and what we wonder runs a bridge, built from math and experiment, reaching farther with every tested idea. We set out asking a simple question, and found answers written in the afterglow, the geometry, the expansion, and the stars yet to fade. Cosmology offers 4 kinds of edges: what we can see, what can reach us, what our models describe, and what meaning can touch. As our map of the universe grew brighter, the unknown grew too, each discovery expanding the frontier of what we still don't know. Edges aren't walls, they're relationships, places where influence fades, signals weaken, and connection dissolves into space without a final line. This is our page in time, when fossil light still glows and a small world in a spiral arm begins to understand. Each photon caught, each spectrum mapped tightens the net, weaving scattered signals into structure, turning light into knowledge we can test. Wonder isn't the opposite of knowledge. It's the spark that drives it, drawing lines between stars and equations until meaning appears. One species, one world, in one fleeting moment of cosmic time, a view that humbles, sharpens, and unites our questions. We stand in the light we've earned and name the darkness we haven't, not with despair, but with curiosity and care. What happens inside a black hole? Beyond the horizon, space and time trade roles, and the rules we know begin to bend. Falling inward can teach as much as standing at the edge. The lesson written in stretched starlight, time, and a closing circle of night. The edge of the universe isn't always far away. Sometimes it's right here where gravity curves light and time into ripples. Beyond this chapter's edge, new questions are already rising, their answers waiting in the light of the worlds we've yet to explore. Past this horizon, the next story is already unfolding, its first light just beginning to reach us.